Our first question of the day on vertical projectile motion comes from Soweto High School. Great, and thank you so much for the question. And don't forget, send us your questions if you need help with any. What I would like to suggest now is if you could just take a picture, maybe if you've got a phone handy, to take a picture of the question so that we can work through it together. All right, so let us have a look at the question. So there's the first part of it, the introduction, and there is the picture. So please, if you could just take a picture of the question and possibly the diagram. All right, so let's look at the question. In a competition, participants must attempt to throw a ball vertically upwards past point T marked on this tall pole. So here's my point T. Oh, I forgot to select my pen. That's not a great way to start. So there we go. All right, so here's point T on this vertical pole. And this point is 3,7 meters from the ground. So they told us from the ground to this point is 3,7 meters. They say that point T may or may not be the highest point during the motion of the ball. One participant throws the ball vertically upwards at a velocity of 7,5 meters per second. So there they're indicating it. And while we're busy here, I'm going to take up as the positive direction. So obviously you can take it as negative, it doesn't matter, but I like taking the original direction as positive. And it is thrown from a point of 1.6 meters. So this is where the ball is thrown, and it's thrown in an upward direction at 7.5 meters per second. And they say, there we go, sorry. Ignore the effects of air resistance. Now that is really, really important. So we can ignore air resistance. Okay, so the first question says, in which direction is the net force acting on the ball while it moves towards point T? So when the ball is in the air, the ball was thrown up. So once it's in the air, the only force acting on this object is the force of gravity. So that's nice and easy. So the only force acting on this is the force of gravity. So, and it's the force of gravity. And in which direction is it going to be acting? Upwards or downwards? Remember, it's always acting downwards. So there we go. All right, force of gravity always acts in a downward direction. Doesn't matter if you're on a planet, on Earth, wherever, it will always be in a downward direction. The next question says, calculate the time taken by the ball to reach its highest point. All right, so when it reaches the highest point, so you're throwing an object into the air, and what happens to that object? The maximum velocity, it leaves your hand with a maximum velocity. It slows down until at the top of the motion, the final velocity is going to be 0. It stops, because what happens now? It falls back down towards the Earth. All right, so what information do we know? So always make a list of all the information, then you can select your equation of motion in order to answer the question. So let us make our list. All right, so we know that the ball was thrown vertically upwards with an initial velocity, they told us, of 7,5 meters per second. At the top of the motion, the final velocity is going to be 0. Now they haven't told us that, but we know that object will stop and return to the ground. Now we took up as the positive direction, so G always acts downwards, so it's going to be negative 9,8 meters per second. So always watch the direction. So you always start by selecting a direction as positive or negative, and then always remember G always acts downwards. Now once you've selected the direction for these questions, stick with it. You can't keep changing the direction of the object, all right, that you've selected as positive. So if you're taking up as positive throughout the entire question, you stick with that. If you took up as negative, that's perfectly fine, but you must just stick with what you selected. All right, now we've got to work out the time it took to reach the highest point. So let us have a look at what equation we can use. So T is my question. So you're going to go to your information sheet, and you're going to go and select your equation of motion. So I think we can, if we have a look at our equations here, I think we could work with this equation. We've got the final velocity, we've got the initial velocity, we've got the acceleration, which is g, which is 9,8, and they're wanting t. So that is the most logical one to use. All right, so let us just go back to our question. All right, so now we're going to write down our equation for this question. All right, so we're going to use V final equals V initial plus G delta T, or you could use A delta T, it doesn't matter. So V final is 0. V initial is 7,5, and it's plus 7,5 because it's in the upward direction, plus G. Now G is acting downwards, so it is negative. So negative 9,8 times delta T. So we get minus 7,5 equals negative 9,8 delta T. And now we make delta T the subject. So we're going to divide through by negative 9,8. And remember, you can't get a negative time. So if you get a negative time, go back and have a look at what you did and what you chose with your direction. So let us get our calculator. So 7.5 divided by 9.8. I'm dropping the negatives because I know they're going to cancel out. And the answer is 0,765, and we always have to round off to 2 decimal places, so we'll just make it 0,77 seconds. All right, and so 0,77 seconds, and there's our answer. Great. All right, so that wasn't too difficult, so 3 easy marks. Now they want us to determine whether the ball will pass point T or not. So now the total height was 3,7 meters from the ground to point T. And the ball was thrown up from 1,6 meters. So in other words, we want to see, can the ball rise by that? And if I do my calculations properly, that is going to work out to 2,1 meters. All right, so we want to see how high that ball is going to move. Once again, we go to our information sheet. So what information do I have? First of all, V initial was 7,5 meters per second. V final was 0, it stopped. G we know is minus 9,8. And now we know the time that it took to reach the maximum is T is equal to 0,77 seconds. Okay, so let us have a look at our information sheet. All right, so looking at the information sheet now, we're wanting to work out how high it went. So it's got to have something with displacement. So I see here, I could use either one of these equations here. There's displacement, the final velocity. We have V initial I have, A I have, and I can go work out how high it went. So I think that would be the most logical one to use. So it's all the information that we have. So let us go back to the question. So to work out the height, we are going to use V final squared equals V initial squared plus 2G delta Y. Now we just have to sub in, so it's 0 squared equals V initial 7,5 squared plus 2 times minus 9,8 delta Y. All right, so now it's just a matter of solving. So we get 0 equal to, so we need our calculator. All right, so we go 7.5 times 7.5. Sorry, it didn't do it so well. Go again, 7.5 times 7.5. I'm just doing it very old school. So that is equal to 56,25. 2 times 9,8 is 19,6, but it's negative 19,6 delta Y. All right, so we're going to take it across. So we get minus 56,25 equals minus 19,6 delta Y. So delta Y is equal to 56,25 divided by 19,6. And that will give us the height. So now we need our calculator again. So 56.25 divided by 19.6 gives us 2,86. And if we round it off, it was 2,87 meters. How far did it have to go? Well, the ball had to go 2,1 meters. So we worked out it had to go 2,1 meters. And how far did the ball actually go? It went 2,87 meters. Therefore, what can we see? That the ball will reach point T. So the question was whether it will pass point T or not. And yes, the ball will pass point T. All right, so nice and easy. So once you've made a list and once you've selected your equation of motion, it's really quite simple, but don't forget your direction. Okay, the last question will normally be a graph question. So now you've got to take everything that you've worked out and put it onto a graph. Now don't forget, once you are drawing the graph, always go with the direction that you chose as positive. So because I chose up as positive, my graph must reflect that. All right, so let us have a look. All right, so they want us to draw a velocity time graph. So there we go. So we put V on the y-axis, and don't forget to put the units in. We got time in seconds. All right, now it was thrown up with the initial velocity of 7,5. Okay, and there it is there. And this ball decreased in speed until it reached, at maximum height, it reached 0 meters per second. All right, and there we go. And at what time did it reach this maximum height? It was at 0.77 seconds. And there we go. So 3 easy marks. So always make sure that the direction is reflected. So we chose up as positive. So because the ball's been thrown up, the ball is going to decrease. The speed will decrease until it stops. And that must be reflected in your graph.